Anything from 3.1, 3.2?
Not yet. Yeah.
Would you like to choose a problem, like a fifth degree or sixth degree polynomial function?
Yeah, I mean, if you're
to refresh our memory from yesterday, and then we'll move on.
Okay, maybe 243.
I gave my syllabus to Jack, my colleague, yesterday, and I did not bring one, but I can look it up. No.
If you do 32.
Yes.
T44. It's on page 244.
32 on 244. Okay.
It's x to the fifth.
Yes.
Minus 9x to the third.
That's it? F of x? Perfect. So first of all, what is a degree?
5.
The degree is 5 indeed. What is the maximum possible number of terms?
4.
For max, and you understand it doesn't have to have 4, but it cannot have more than 4.
So when you say that, you mean as in coordinates? Or?
No, turns means turn.
Oh, turn.
Turn.
Oh, I thought you said terms.
Turn. Turn.
Okay, got it.
Turn. In other words, max or min.
Yeah.
That's what a turn.
I was hearing turn.
Yes.
Right.
For maximum number of turns. Max, min. Very good. Okay. Domain. Feel free to correct my pronunciation anytime. I will never feel offended.
I can never.
I learn. I learn from you.
Because I'm from the South. I don't pronounce things right.
But you should. You should.
Right.
Domain.
Oh, negative infinity.
Right. It's a polynomial function. There is no question there. Very good. I wanted to ask you, is it okay if we just review this, or do we have to go back to the lecture notes from yesterday?
Oh, we just reviewed this. That's fine.
That's fine. Okay. I just want to bring it up just in case. Perfect. Okay. Now I need the x and y-intercepts. So how do I get the x-intercept or the x-intercepts? Very good. X to the fifth minus 9x cubed equals 0. How many solutions do I have to present? Exactly. Exactly the degree. Yes. Good. Any suggestions here? What we do?
Can we factor?
Absolutely.
So pull out x to the third.
And
At least x squared minus 9, so you get.
Because this is our agreement.
So it's x. I mean, it's x plus 3x minus 2.
Very good. Since the degree is 5, whatever multiplicity I have here, they have to add up to 5.
So that's just 0, right?
I need 5.
Okay.
So you have 3 zeros.
Exactly. I have 3 zeros.
And then 3 and negative 3.
X equals negative 3 and x equals 3. Good. What is the multiplicity of 0?
Oh, 3.
3. Very good. What is the multiplicity of negative 3?
1.
And what is the multiplicity of 3?
1.
1. And now I can put them in the chart. 0, 0, negative 3, 0, 3, 0. Since I already replaced 0 for x, that will be the y-intercept, right? Y-intercept is obtained when x is 0. Is the degree odd or even?
Degree is odd.
Odd. So it can look like this,
With 1 square.
or it can look like this for the end behavior. Is it this, or is it this?
It's negative.
Right, because the leading coefficient is positive. Make sure that this is in descending order. Because if it's not in descending order, you may look at this and say, oh, this is the leading coefficient. No. The leading coefficient belongs to the degree. In other words, to the leading term. So yes, it is. So it's coming from negative infinity, and it goes to positive infinity. Okay? One other thing that we need to establish, whether the function is symmetric or not. Once I see negative 3, 3, and 0, I have to try and see. It's possible that it's symmetric.
Okay.
So how do I find symmetry? We had it on the test.
F of -1.
F of -x,
Yeah.
right? So this is -x to the 5th minus 9 times -x to the 3rd. Let's take it slowly. -x times -x times -x 5 times is what?
-x.
Yes, indeed, -x to the 5th
And then plus 9.
plus 9x to the 3rd. So now remember, I have 3 questions that I asked myself. First question is, does this equal f of x? Does this equal the opposite of f of x, or not symmetric?
It's odd.
Yes, it is. Because when you multiply both sides by negative, that's exactly what you get. You get -x to the 5th plus 9x cubed, and this is it. So indeed, the function is odd. Very nice to know that it's odd. Which means what?
Symmetry of the x-axis? Y-axis.
Origin,
Or-
right? So whatever I have in the first quadrant, I will have to have a copy in the third. Or whatever I have in the second quadrant, I will have to have a copy in the fourth. Over the origin. Okay. So you may say these points are not enough. Let's give it a shot, and then we'll decide. The trick with these functions is we really learn if we talk about them, if we think about them, and if we come up with a graph, and then look in the graphing calculator.
Do we have to write term over like -3 or 3 or?
Say it again.
Do we have to write term at the top, like it's terms here or?
In a moment.
Oh, okay.
Yes. Yes, I did not write that. You're right, of course. So multiplicity 1 will be clearly a cross. What about 0? Because it appears 3 times. Is it a turn? We just started. Is it a turn or is it a cross?
It's a term because it.
Multiplicity 3 must be a cross.
Oh, it's got- oh,
Any odd multiplicity must be a cross. However, it's not, it's,
It's a long. Okay.
yes. Remember what x cubed? We never graphed x cubed like this, right? We graphed x cubed like this. Although there is only one intercept there, but the immediate points are very, very close. Okay, so this is a cross but flat or slow, whatever you want to write. The book doesn't do it like that, so you choose what you want to write. I'm going to write cross, flat. It takes a while, in other words. Okay, so I'm ready to graph this function. Here is how I look at it. Ready? So this is the interpretation of the chart. Now, if you don't summarize the information in a chart, it will be very difficult to look at all sorts of pages where you have the x-intercept, the y-intercept, and put it together, right? But always keep all the information in here. Okay, so it's coming from -infinity. It has a cross, very simple cross at -3, 0. It must turn because it comes back and crosses again, slowly, but it has to come. So from -infinity, it crosses at -3, 0. It goes up, but it has to turn because it has to come back and cross again. And it comes down to something and it has to turn because it's coming here at 3, 0, going up to infinity, cross flat, cross normal. Okay? So here's the graph. I only have 3 points. I have this point, I have this point, and I have this point. So it's coming from -infinity. It has to go to a maximum, local maximum, has to turn. It has to come back and slowly cross here. And it has to come down to exactly the same height. So if this is here at 5, this has to be here at -5. Because I know that the function is symmetric with respect to the origin. So it goes down to the same height, and then crossing normally and goes up. So this is f of x. If we hadn't discussed this, if you had grabbed the calculator and looked at it, you would have not understood what's happening really. Okay, so this is f of x. Very nice function you picked. And now we can look at it with the graphing calculator. So in y equals, I have x to the 5th minus, not there, I always do that, minus 9x to the 3rd, and I'm thinking of the viewing window. I don't know how high it goes, I don't know how low it goes. I'm going to use the standard viewing window for now. Standard. I meant this, standard. Let's see. So it's coming from, okay, so it's way up there. So that's not good enough. Okay, so I have to do better. So I'm going to say for y maximum and y minimum, negative 50, y maximum 50 with a scale of 10. Here it comes, it crosses at negative 3. It has a turn. Look at how is this very clear now?
Yeah.
See the difference between this cross, and this cross. Okay? Because here we have 3 solutions x equals 0. That's why it takes its time. Okay, so now I can find this maximum. I don't have to find the minimum. So I'm going to find the maximum second and calc, and it's a maximum of 4. So I know the maximum is somewhere between negative 3 and 0. I'm going to put negative 3, enter, 0, enter, and enter, no guess. And it gives me the maximum. So if the maximum is negative 2.32, and the value that is the maximum, that's the x. I'm going to go back to my chart. So this is negative 2.32, and I get 45.2. Can anyone give us the minimum? I refuse to determine it.
2.32, negative 45.
Very good. That's it. Of course. Why? I can do this only because the function is symmetric. Otherwise, I can't. If the function is not symmetric, I cannot figure out the minimum without determining it. But because it was symmetric, I knew that this point and this point have to be symmetric over the origin. See, the first time it took us 20 minutes. Now this one is just 5 minutes.
So how did you decide whether it was a cross compared to the term? Like on the,
If the multiplicities are odd, it's always a cross. If multiplicity, always think of x squared. X squared has 2 x equals 0 in there, and it's a term. X cubed has 3 x equals 0, and it's not a term. It's a slow cross. Do we have anything else? Anything else? All of them are the same. All odd degrees, same thing. All even degrees, the same thing. So can I continue?
Yes.
Okay. So section 3.3 is entitled Dividing Polynomials. We have few situations here. A polynomial divided by a monomial. That's one situation. Second situation is a polynomial, p of x, divided by anything else, not a monomial, by another polynomial. Not a monomial. This one doesn't have a name, but this one is called long division. Long division. And the third situation in which we can divide any polynomial by x minus a number. But of course the number can be positive or negative. So as an example, I could have a polynomial divided by x plus 1. I could have a polynomial divided by x minus 3. In this case, a is how much? And in this case, a is how much? Exactly. Okay? And this one is called synthetic division. Synthetic division. Okay, so let's start with examples from the first one. That's the easiest. And I would like to give you an example of the usage of it, because that's, in my opinion, very important. Okay, so I'm going to make it up, and then we'll look in the book, and then I'll let you choose. So for the first example, for number 1, let's say I have x to the 4th minus 3x squared plus 2x minus 7. Everything divided by, let's say, 2x squared. This is exactly this case, in which I have a polynomial, whatever polynomial, and just one term, a monomial in the denominator. The only thing I can do here is split it in 4 fractions. Why 4? Because the numerator has 4 terms. And simplify. So I have x to the 4th over 2x squared minus 3x squared over 2x squared plus 2x over 2x squared minus 7 over 2x squared. And if you say, and what did you accomplish? I will say not much. I will have to agree. But that's the only way. And now I will try to simplify each fraction by itself. The first one, I will cross out 2 x's from the denominator with 2 x's from the numerator, so I get x squared over 2. And the next one, I will cross out x squared with x squared, and I get negative 3 over 2. In the next one, I will cross out an x and a 2, so I get positive 1 over x. And in the last one, I cannot cross out anything. So that's the example of dividing a polynomial by a monomial. Why is this important? It's because in many situations, we may have to, we may not encounter this in this class, but we will encounter it in the next class, in which we will have to separate the fraction, simplify, and do something with the rest. And even in this class, I would say when we get to rational functions, this may be useful there.
But that's it?
That's it. There is nothing else I can do here. And if you say this is not a real division, I will have to say, but that's all I can do. Okay. So very useful, though, for other things. Let's look at the second one, where we have a polynomial at the top, anything, and the denominator is no longer a monomial. It's just more complicated. Before I present this method or algorithm to you, I want to divide. I know we don't do this by hand anymore, but I just want to refresh your memory on a simple division. Let's say I have 3, 9, 2, 5 to divide by 30. What do I do? Let's say I lost my calculator, okay? And I have to divide this, okay? First I say, okay, 30 goes into 39, and I say ones. Then I go back, I multiply 1 by 30. I get 30, but actually I have to change its sign to the opposite sign because I'm subtracting. So I subtract. Although 1 times 30 is not negative 30, I have to write negative 30 because I subtract. And then I have 9, and then I bring down the next in line. And then I ask myself, 30 goes into 92, and I'm going to say 3. So 3 times 30 is 90, but I have to write negative 90. I have to change to the opposite sign. Then, of course, I bring down the next in line, and 5, and I get 0, and I continue if I want decimal, or I leave it as a fraction. The same procedure we will use as the long division of polynomials. It will look differently because we will have x in there. But it's the same idea. Every time I multiply and I write underneath, I have to change the sign to the opposite sign. So if multiplication is negative, I write positive. If multiplication up here is negative, positive, I write negative. It has to be the opposite sign. So now let's pick a problem. And I will pick a problem from your book now. On page 251, let's say problem 18. On 251, and I have x cubed plus 3x squared plus 4x and plus 3. Everything divided by 3x plus 6. Okay. This has two, the polynomial denominator has two terms. I cannot use something like this. That would be totally incorrect, because this is a one term or one monomial, and this is two. So this is a binomial. So two things I have to make sure of before I start the algorithm. One, both polynomials are in descending order. Descending order. Are they?
Yes.
Good. Question number 2. Is there a missing term from the top, at the top of in the numerator? What does that mean? Can anyone give us a degree of this polynomial? So is there degree 3 in the polynomial? Yes, otherwise you wouldn't have degree 3. Is there a degree 2? A term with degree 2? Is there the term with degree 1? Is there a term with degree 0? It has power 1, but degree 0 because it has no x. Good. So I will say no missing term from the top. If there is a missing term from the top, then I will have to leave some room for that one. So I will write this, for example, if this one is missing, then when I start the algorithm, I will write this term. I will leave room for this one because it's missing. I will write this and this.
You would fill in with 0.
If you want, you can put 0. That's fine too. Okay. So here is the starting point. I have x cubed plus 3x squared plus 4x plus 3. And then I have 3x plus 6 that I divide by. I'm running into some difficulty at this point. Here's my difficulty. I have to ask myself, like I did here, 30 times what is 39, and I put 1. So the question here on the side is 3x multiplied by what is x to the third? Well, to get x to the third, I know I need an x squared. But I also have to multiply 3 by something to get 1. What will I multiply 3 by to get 1? Right. 3 over 1 times 1 over 3. So my question is now, do I really want to work with fractions here? Or I use one of the two key words in this class. What are the two key words? Or and the factor. I would do this. Instead of drag those fractions at the top, is there something that I could factor out? Look at this division and say, yes, you can factor out nothing at the top, obviously. But I can factor out exactly. I am going to rearrange the whole thing and say 1/3 that can wait for me till I finish. X cubed plus 3x squared plus 4x plus 3 divided by
X plus 2.
exactly. So that 1/3 can wait for me till I finish with the division, and then I will distribute it to everything. Instead of having going through the hassle of having all sorts of fractions up here. So then I will start the algorithm for this, and when I'm done, I will distribute 1/3. That is the wise thing to do. So now I start my algorithm. I have x cubed plus 3x squared plus 4x plus 3, and divide by x plus 2. This is so much better. So then, now I can easily say x times what is x cubed? Right. Remember, I have to go now back with x squared, distribute to these two terms, write the opposite sign when I write under like terms. So x squared times x is right, but I have to write the opposite. 2 times x squared is 2x squared, but I have to write the opposite. And it has to be under like term. I cannot write negative 2x squared under 3 or 4x or somewhere else. I draw a line. X cubed goes away. 3x squared minus 2x squared is x squared, and I have to bring down the next in line. Now I'm asking myself, what? X times what is? Right. Here I don't lie. At the top I don't lie. I do lie when I write underneath. Okay, so it has to be positive for, I looked at that instead of looking at this. So it's positive x. Good. So x times x? Yes, but I have to write the opposite. X times 2x, yes, it's positive, that I have to write the opposite. These two go away. Bring down the next in line, and then 3. Perform the operations and bring down 3. Okay. Final question. X times what is 2x? I need the sign. Yes, of course. And then 2 times x is 2x. The opposite. 2 times 2 is 4. The opposite. Now the question is, how do I incorporate 1/3? First I have to write the answer. So remember, when I divide 10 by 3, I can write 3 integers and 1/3. But I cannot do that with polynomials. I cannot write this with polynomials. I have to write 3 plus 1/3. So the quotient, remainder, divisor. So from here, I keep 1/3 outside. It can still wait patiently. So I continue here, 1/3 outside. How do I write the final answer? What is the quotient?
X squared plus x plus 2.
Then I have to write plus or minus because the remainder is negative. I will write minus. Negative 1 divided by correct. Now I want to eliminate brackets, and now slowly I distribute 1/3 to everything. 1/3 times x squared over 3, plus 1/3 times x over 3, plus 2 over 1 times 1 over 3, 2/3, minus 1 divided by 3x plus 6. So I simplified, I made my life easier by removing that 1/3, and it waited for me. I was finished. When I finished, I put it back in.
So you put your remainder, so you have a negative 1 as the last of your remainder?
Yes. It's like when I divide 10 by 3. It's 9 plus 1. 9 divided by 3 is 3 plus 1 over 3.
You put the negative 1 over x plus 2?
Yes, if the numerator is negative and the denominator is positive, the fraction is negative. Is that okay?
Can you forward how you get x plus 2? Times use of x plus 2.
This one?
Yeah.
From here. This was 3x plus 6. I pulled out a 3, and I have x plus 2. So 3 times x plus 2 is 3x plus 6. Because I did not want to have fractions. Is this okay? Yes? Is this okay? Okay, let's choose another one. I would like to choose one with missing terms. So if you allow me Let's look at 38. X to the fourth minus 16 divided by x plus 2. You can say, I don't need to apply long division here because you forced me to sign an agreement at the beginning of the class. I know how to factor x to the fourth minus 16, and I will simplify it like that. Yes, I would say yes, you're right. You can do that, but we have to use long division now. Let's see what we get. Okay? Are both in descending order?
Yes.
Good. Any missing term from the top?
Yes.
Yes. The term with degree 3, the term with degree 2, and the term with degree 1. They're all missing. So x to the fourth for 1, for the other, degree 3, degree 2, degree 1, and minus 16. And I divide by x plus 2. If the divisor has missing terms, we don't care. But if the numerator has missing terms, we do care. Now, what if I leave all these spaces and I don't use them? That's fine. It's okay. I don't have to. But if they're not there, I will mess the whole thing up. So it's better and safer to have it there. Just have those spaces there. Good. X times what is x to the fourth? Very good. I go back. X to the third times x is x to the fourth. Negative x to the fourth. X to the third times 2 is 2x to the third, but I have to write negative 2x to the third, and I have to write it under the next term because degree 4, degree 3. Gone. I copy the next in line. There is nothing I can do here. Now I'm asking myself, x times what is negative 2x cubed? I cannot lie. At the top, I cannot lie.
Negative 2x.
Squared. Good. Now I distribute. Negative 2x squared times x is negative 2x cubed, but I have to write positive 2x cubed. Then negative 2x squared times 2, negative 4x squared, and I have to change to positive 4x squared. These go away. I bring down the next in line. I ask myself now, x times what is 4x squared? Positive 4x. I have to have a sign there. Good. 4x times x is 4x squared. Negative 4x squared. 4x times 2. But I have to write negative 8x. These two go away. I bring down the next in line, negative 8x. And now I bring down the next in line as well, which is negative 16. Final question. X times what is negative 8x? Good. Now, notice one other thing. From degree 3 to degree 2 to degree 1 to degree 0. So, never make the mistake, degree 3, degree 4, then degree 2, degree 1. No, no, no. They have to decrease. Because we put this in descending order, the answer will automatically have to be in descending order. So, you catch your mistake. So negative 8 times x is negative 8x. What do I write? And then negative 8 times positive 2 is negative 16. What do I write? Okay, and I knew that. I knew there would be no remainder. How do I write the final answer? Can anyone dictate? Yes, that would be at the very end. And since it's 0, I don't have to write it. Since it's 0, I don't have to write it.
X cubed minus 2x squared plus 4x minus 8.
That's it. So I would write either plus or minus here. It's mandatory in front, but there is nothing needed there because...
Okay, so only when you have remainders when you put it in.
Yes, because otherwise it would be wrong if I don't. Now here's a question for you. How do I check that this is the correct answer, or if you want that this is the correct answer? In other words, I'm asking you here, how do you check if you have 9 divided by 3 and you get 3? How do you check if this is correct? Of course. Exactly. So you cross multiply, right? Because this is over 1. So you multiply this by this and see if you get that. And what if you have a remainder? Then you will multiply this by this and you add the remainder to get that.
Alright, What do you multiply the remainder?
Okay, let's go back to, or let's work on another one. Okay, let's choose one more and then check it.
Can we do 35?
35. Very soon, with the problems he's picking, we're going to ban him from choosing anything.
Wow.
I'm kidding, I'm kidding, I'm kidding.
Yeah, I'll choose it.
I'm kidding, I'm kidding. Good. Okay, so let's say, don't write this part, I'm going to erase it. So let's say I get this plus this over x minus 1/2. In order to check, I will multiply this by this, add this to get this. So let me give you an example. 10 divided by 3 equals 3 plus 1/3. 3 times 3 is 9, plus 1 is 10. This times this plus this has to give us this.
Okay, that makes sense.
3 times 3 plus 1 is 10. This times this plus this has to be this. Clear?
Clear.
Perfect. So now let's go ahead with this problem. Yes, they are both in descending order.
Can't take anything away.
Here is what I would like to do. Although the fraction may not, we can start it the way it is. And if the fraction gets complicated, then I recommend multiply the top, which I can, and multiply the bottom by what to eliminate that fraction from the exactly.
Oh, okay.
So let's give it a shot as is. And if it gets hairy, then we can go back, multiply top and bottom by 2, which is I'm multiplying it by 1, but I simplify the outlook, right? And then it will be easier to
So
calculate.
if you were going to multiply by 2, you just distribute 2 to the top and the bottom, just get rid of
Absolute.
x minus 1?
Yes, because you will have 2x minus 1.
Yeah.
You have to multiply everything.
Yes.
So you multiply all terms from the top that you have at the top and all terms that you have at the bottom by 2 in order to simplify.
So-
And then at the end, it will simplify by itself.
Okay.
So let's try it the way it is and see what happens. And if it gets crazy, then we can go back and do that. So then 2x cubed plus 3x squared minus 2x plus 1. I see these numbers and maybe it's okay. I have no idea. So x times what is 2x cubed? Very good. I go back and multiply 2x squared by x and I get 2x cubed, but I have to change to the opposite sign, always the opposite sign. And then 2x squared times negative 1/2, it's pretty good. It's negative x squared, so then positive x squared. Are you okay so far? Is this okay?
Yes.
Good, so now these go away. Then I have a nice number again, 4x squared. I bring down the next in line, and I'm asking myself, x times what is 4x squared?
4x.
Indeed. So positive 4x. 4x times x is 4x squared, but I have to write the opposite sign. And then nice, 4x times negative 1/2 is negative 2x, change to positive 2x. Okay, these two both go away. I bring down the next in line. But x times what is 1? I have to stop. So I cannot. This is the remainder. We can check. We'll check in a minute. So from here, how do I write the final answer? And then we'll check it. Yes, x minus 1/2. Okay, so now remember the plus has to be in front of the fraction line. And the remainder is at the top and the divisor in the denominator. Okay, so now what do? I want to check.
Then multiply x minus 1/2 times 2x squared plus
Let's distribute and then add 1. And if we do not get this, then our answer is wrong. Okay, so let's do it. X times 2x squared is 2x cubed. X times 4x is positive 4x squared. Negative 1/2 times 2x squared is negative x squared. Negative 1/2 times 4x is negative 2x, and then plus 1. 2x cubed? Yes. 3x squared? Yes. Negative 2x? Yes. Positive 1? Yes.
You made a hard problem.
Is it okay?
Yeah, I thought I got you there.
Good. It is possible. It can happen.
At this point, I doubt it.
Well, that's all I know, so I must know something. Okay, good. So now I would like to talk about synthetic division. So you remember when we started this section, we said this. We know now how to divide a polynomial by a monomial. And this is useful, not just in this class, but in the next class. We know now how to use a long division. We know how to multiply top and bottom if we don't like, or factor out something if we don't like, and we get into fraction situation. And now I would like to talk about the last thing, synthetic division. This long division works for any polynomial in the denominator. The synthetic division, however, has limited applicability. I can apply it only if the denominator does not have 5 in front, or x squared, or blah, blah, blah. I will have to factor it out. It has to have a leading coefficient of 1. It has to have here minus or plus and a number. Okay, it's mandatory. Otherwise, synthetic division is not applicable. Okay, so let's choose a problem. We can even start with this one because it's x minus a number or x plus a number. Or you can choose another. It's up to you. We can use synthetic division to check our answer on this one. Okay, so here's the algorithm for synthetic division. A little box. Leave some room here and a long line, fraction line if you want. It's not a fraction. In the box, I have to have a. Remember, if this is positive, then I have negative 1/2 here. Because this is negative, then I will have 1/2. So in the box, I have a. Next to the box, all coefficients, even if they're missing, all coefficients, even if they're missing, have to be put in next to the box. 2, 3, negative 2, 1. 2, 3, negative 2, 1, with spaces between. Synthetic division, I should write it here. Synthetic division requires the first coefficient to be copied. No matter what it is, I have to copy it. The next step is this. I multiply 1/2 by 2. I get 1, and I write the answer here. And because I took care of all the sign changes by putting 1/2 here, we do not change any signs in the synthetic division ever. I perform the operations I see and I get a 4. Then I multiply 1/2 by 4 and I get 2, and I write it here. I perform the operations I see and I get 0. And then 1/2 times 0, and I write the answer here. I always box in the last number. Why do I box in the last number, and what does it represent?
That's your remainder.
Of course. Now let's analyze what happened. I divided degree 3 by degree 1. What is the degree of the quotient? When I divide degree 3 by degree 1, the quotient will always have a degree of I'm dividing degree 3 by degree 1. The answer always have to have degree 2. So this is the coefficient of degree 2. This is the coefficient of degree 1. This is the coefficient of degree 0. And this is the remainder. So what is the answer then?
2x squared
2x squared.
plus 4x plus 1.
So 2x squared, bless you, plus 4x. I don't have anything. If you want, you can write 0 if you want, but it's still 0. Plus 1 over x minus 1/2.
Can you just run through the chart again real fast? Just,
Yes, yes. So because this is x minus a number, and this becomes our a. So it's a polynomial divided by x minus a. So a is 1/2. A goes here in the box. Then the coefficients follow, 2, 3, -2, 1. The algorithm of synthetic division requires us to copy the first coefficient no matter what, or the leading coefficient no matter what. Positive, negative, whatever number is there, I need to copy it. And then I multiply. 1/2 by 2, and I write the answer here. 1/2 times 2, and I write the answer. 3 plus 1 is 4. 1/2 times 4, and I write the answer. It happens that this is 0. 1/2 times 0, and I write the answer. And 1 plus 0, and I get the remainder. The last number is always boxed in as being the remainder.
yeah, how did you know to add? Just, sorry,
Say it again.
are you always adding in that?
If the numbers are negative, I have to write negative.
When you did like 3 plus 1, how did you know to
Yes,
add?
yes, I have to
It's
add.
always that?
Yes.
Okay.
That's what I said. We already took care of the change of sign in here by writing 1/2.
Oh,
So that takes care of it all the way.
so when you write your A, it's the change of.
It's if I have x minus 5, a is -5.
Okay.
If I have x minus 3, then a is 3. Yep. Good. So before I talk about the theorem here, that is very important. Tell me if we need more examples.
Can we just do one more?
Yes, please choose. But if you want the synthetic division, you have to choose a denominator that is
X plus a number.
x plus or x minus.
Can we do x cubed? Let's do 30. Let's do 32.
32.
51.
Yeah, 32.
Right, did we do that one right?
Okay, very good. Let's do 32 on page 251. So we have x to the 4th minus x cubed plus x squared minus x plus 2 divided by x minus 2. This time, if a term is missing, you have to write 0. You cannot omit anything in synthetic division. Good. So can I apply synthetic division?
Yes.
Because the denominator is x minus a number or x plus a number. Good. What goes in the box?
2.
All coefficients have to be written. Because it's degree 4, I have to have degree 4, I have to have degree 3, I have to have degree 2, 1, and degree 0. I always copy the first coefficient. Well, then what do I get? 2. So -1 plus 2.
1.
1. 2 times 1.
2.
1 plus 2.
3.
2 times 3.
6.
5. 2 times 5.
Okay.
Box in the last one, which is 12. I divide degree 4 by degree 1. What will be the answer?
X cubed minus.
Very good. So the answer will be x cubed plus,
X squared
yes, plus,
plus 3x
yes, plus,
plus 5
plus.
plus 12 over x minus 2.
Very good.
Alright, awesome. I like that.
Good. So now, two super important theorems that I expect my students in Calc 1 to remember. Here it is. If we have a polynomial divided by x minus a, the remainder, not the quotient, just the remainder of this division is, will be, must, if you want, is P of A. I want to check here. I will not check the whole thing unless you want to, but I want to check this. So what should 12 be?
What, P12?
P of
Oh, okay. So,
P of.
2.
So I claim that by the remainder theorem, because I have this division already determined, the quotient and the remainder, using a synthetic division, I claim that when I plug in 2 in this polynomial, I get 12. If I don't, something is wrong. So P of 2 is 2 to the 4th minus 2 to the 3rd plus 2 squared minus 2 plus 2. 2 to the 4th, 16. 2 to the 3rd, 8. These 2 go away, and plus 4. 16 plus 4, 20. 20 minus 8. This will always be the case. Always. But if you have something like this, gee, they were all problems we did had synthetic division could be applied to. But if I have anything else, if I divide this polynomial by x squared minus 15, and the remainder is 5, no. I cannot plug in 15. So, yes, Parker, you wanted to say something?
Oh, I was gonna
Please.
make a comment on something. So,
Yes.
like for example, so the first, okay, yeah. So like number 18 that we did,
Yes.
where the denominator was 3x plus 6, and factored out the 3 to 1/3.
Yes. Hold on. Very good question. Very good question. Okay. So I can only verify that the remainder of this division is P of negative 2. This is not part of what we do, and because I'm checking the remainder anyway,
Okay.
and this has nothing to do with the remainder,
Right.
right? So I have to show now that P of negative 2 equals negative 1. So P of negative 2 equals negative 1. So, and P of x is x to the 3rd plus 3x squared plus 4x plus 3. It must be the case.
So if we can factor out the bottom to get it just x minus a, we can just synthetic divide.
Yes.
And
And then put it back in. Yes.
okay.
Yes. Okay, so I'm checking negative 2. So this is negative 2 to the 3rd plus 3 times negative 2 plus 4 times negative 2 and plus 3.
It's 3 negative 2 squared.
Yes, thank you, thank you. So negative 8, and this is 4 times 3, positive 12, and this is negative 8 and plus 3. So this is negative 16, and this is positive 15, and this is negative 1 as expected. But one more time, if I have a polynomial divided by 3x squared minus 2, I cannot determine, or check, I should say, I cannot check the remainder using the remainder theorem. This will not work. But if I have P of x divided by x plus 5, the remainder must equal exactly. Now here's a question for you. What if this has no remainder?
Then it's going to be 0.
Yes, the remainder is 0, which means that P of negative 5 is 0. And what does that mean, that P of negative 5 is 0? So before you say anything, let me come back to that simple numerical example. I said that 9 divided by 3 is 3 plus 0 divided by 3. I don't have to write that, but I'm making a point that the remainder is 0. If the remainder of a division is 0, what will I say that this number represents for this number? And I'm looking for a key word. So if the remainder is 0, then 3 is of 9.
Factor.
Exactly. So now if I tell you that p of x divided by x plus 5 has remainder 0, I want you to tell me that then x plus 5 is a what? Of course, must be a factor.
So,
Exactly. So when we divided x to the 4th minus 16, I know you're going back to that,
yeah.
of x plus 2. The remainder, which is, I didn't want to write that. The remainder, which is p of negative 2, was 0. Therefore, x plus 2 is a yes of x to the 4th minus 16.
I got a question. If we factored x to the 4th all the way out to its basic and eliminated the x plus 2 and multiplied by the other, would that be our answer?
Exactly. Exactly. Okay, so let's look at one more problem. Would you like to choose or we move on? We move on?
Yes.
Okay.